worked, they would provide fuel for a bomb that would be designed in a remote area of New Mexico. Groves selected a bomb design site in Los Alamos, an isolated location in the mountains at an elevation of 7,000 feet and accessible by only one road.
General Groves wanted it to be inland, too far for enemy planes or submarines. He wanted it to be beautiful, where he said he could keep a bunch of prima donnas amused.
In November of 1942, the Army purchased 54,000 acres for $440,000 under the guise of using them as a demolition range. To head up the installation, Groves, an expert judge of men, chose a most unlikely candidate, J. Robert Oppenheimer. A gifted physics professor, Oppenheimer had a reputation for being temperamental, perhaps not suited to a highly stressful assignment.
Groves was advised that Oppenheimer would be a disaster. People told him that Oppenheimer couldn't run a hot dog stand.
Oppenheimer was a fascinating and complicated man. Fundamentally, he seems to have had some of the qualities of an actor. He was different things to different people.
Oppenheimer drew luminaries like Enrico Fermi, Hans Bethe, and Edward Teller to the facility, as well as technicians fresh out of college. Laboratory personnel grew from 250 in 1943 to 2,500 in 1945.
There were lots of babies born. General Groves at one point asked Oppenheimer if he couldn't do something about that, and he said he didn't think so. The one place that they had to keep expanding was the maternity ward at the hospital.
During the fall of 1942, the theoretical physicists at Los Alamos began the difficult process of trying to determine how much U-235 it would take to make a bomb.
And the scientists tell him, well, it could be X amount, but that's plus or minus by a factor of 10. Groves is absolutely staggered. He uses the illustration that, well, you're giving a wedding, and you say it's for 100 people, but maybe 1,000 will turn up, or maybe 10. So how can you make any sort of plans with that range?
This kind of uncertainty only served to fuel fears that the Nazis might be closer to building a bomb. On December 28, 1942, President Roosevelt approved an additional $500 million investment in the Manhattan Project. The first priority, to build the massive industrial facilities that would produce the fissionable material to fuel the atom bomb. Robert Oppenheimer's team of physicists doubled the amount of uranium-235 thought necessary to achieve critical mass and sustain an explosive chain reaction to 200 kilograms. Their calculation, made without adequate samples of U-235 for tests, would prove to be 10 times the required amount. The scientists at Los Alamos also studied tampers, barrier materials that would slow the expansion of the critical mass and reflect neutrons back to feed the fission process inside the bomb. Determined to have the atom bomb ready for use in the war, General Groves notified contractors in Oak Ridge, Tennessee, that they had a scant 6 months to build the massive electromagnetic calutrons designed by Ernest Lawrence at the University of California in Berkeley. These calutrons would be used to separate U-235 from U-238.
Lawrence was, to some extent, an engineer. He was comfortable with the soldering iron and with wrenches and with the tools of the trade, with building machines.
In February 1943, construction began on the calutron site that was given the deliberately nondescript code name, Y-12. These gigantic structures contained multiple calutrons, box-shaped collection units that were configured in a racetrack layout. A magnetic field passed throughout the entire oval of calutrons, causing the divergence of streams of U-235 and U-238 so that the separated isotopes could be collected. A single calutron could capture a mere 10 grams of U-235 daily. A staggering total of 1,152 would be built by war's end. Because of the intense time constraints, Groves could not afford to build pilot plants. facilities to test the scaling up of the laboratory processes.
They're physically building Oak Ridge and Y12, the electromagnetic separation plant, before the design drawings had even been approved. And it's incredible that you would never do this in civilian life, and you would never do it short of a wartime emergency that is dire. They turned the Alpha 1 racetrack on to make the first uranium, and everything goes haywire. That the magnets are so strong that they pull nails out of the wall.
Groves arrived and shut the plant down. His response was characteristic of his approach. Since the racetracks were not operating to capacity, more would have to be built to supply the bombs. As a result, the town of Oak Ridge continued to grow to house an expanding workforce. 75,000 people would ultimately come to live at the site. Groves used creative means to recruit them.
It was hard to get construction workers during the war. His solution was to put out ads saying, we can't tell you what you'll be doing, but there'll be steak every night on the table.
Once hired, workers were instructed to be evasive about what they were doing.
If anybody asks you what you make in Oak Ridge, you tell them you're making the lights for the lightning bugs, or that you're making the holes for the donuts.
Meanwhile, at Los Alamos, design work was underway on the Gadget, as the test bomb came to be known. The main obstacle was how to quickly assemble two smaller subcritical masses into one larger explosive one. The bomb design that they came up with was a gun design. Inside the bomb, a cannon would fire one piece of radioactive fuel into another at 3,000 feet per second. The pieces would have to come together fast enough to prevent spontaneously emitted neutrons from melting the fuel, causing the bomb to fizzle rather than explode.
But the engineering
5:30 a.m., July 16, 1945. The world entered the atomic age with an intense flash, a sudden wave of heat, followed by a tremendous shock wave. The ball of fire extended 40,000 feet. The bomb packed a punch equivalent to 20,000 tons of TNT, the high end of most of the scientists' predictions. Completely vaporizing the steel tower and heating the desert sand into glass for a radius of 800 yards.